wabarakatuh. My name is Ahmad Daniel Usman and my number is 2080878. We are from Group 4 and we will talk about the application of thermodynamic in a jet engine. So first for the introduction, what is meaning of a jet engine? Jet engine is a engine that discharges a fast moving jet that will generate a thrust through the jet propulsion. So for example, the jet engine consists of a turbojet, turbofan, pulse jet and ramjet. Jet engine is very important as the engine's capability to allow a plane to rapidly deliver the products and transfer passengers in a short time. Dr. Hans von Ohain and Sir Frank Whittle are both known as the co-inventors of the jet engine. So there are 5 main parts of the jet engine. Firstly, is compressor. Compressor consists of a rotating blade and the air will move through the compressor, which will increase the pressure and temperature. Next is combustion chamber. Kerosene will burn continuously after the engine being started. And the third one is the shaft. It connects turbine to the compressor. It also transfers the rotation of the turbine through the compressor and the fan section. And the next part is turbine. Turbine has a blade that will rotate due to the high energy that coming out from the high energy of air that coming out from the combustor. And lastly is the nozzle, which placed at the end of the engine, and the exhaust gas will exit through the nozzle. So how the jet engine works? Firstly, a fan is present at the front side of the jet engine, which make the fan to take the cold air to enter the engine. And next, compressor, which present inside the engine will squeeze the air, and due to the squeezing, the pressure will increase. And it is said that the pressure will rise almost 8 times from the initial pressure. The third one is the kerosene is added inside the engine from the fuel tanks. The fourth step, the compressed air inside the combustion chamber is mixed with the kerosene, which resulting in the formation of the hot exhaust gas. The fifth one, the exhaust gas will pass through the turbine blade, which make the turbine blade spin like a windmill. So as the energy conservation principles say, when the one form of energy is converted into another, so the turbine blade will gain energy while the exhaust gas will lose energy by the cooling down process. And lastly is the exhaust gas will exit the engine through the nozzle, and the design of a nozzle which is tapered will help the gas to exit the nozzle with at the high speed. So that's one. Thank you.
Hello and good morning. My name is Narashimahari Analakianan and my matrix number is 205664. Today I will be explaining about the application of first law and second law of thermodynamics in a jet engine. The first law is the law of conservation of energy. It says that the amount of energy remains constant in a system. Energy only can be transformed into other forms and cannot be created nor destroyed. In a jet engine, air gets compressed in the compressor and gets ignited in the combustion chamber. Then the air will expand and passes through the turbine, causing it to rotate and will produce work, which will be transferred to the compressor by a shaft. Here we can clearly see that the energy from the hot gases are being transformed into mechanical energy. In a jet engine, values of heat energy rate and the work rate at inlet and outlet of each component remains constant. Thus, the energy is conserved. Hence, the jet engine complies with the first law of thermodynamics. Next is the application of second law of thermodynamics in a jet engine. Second law states that energy has quality as well as quantity. Processes occur in the direction of decreasing quality of energy. Processes only occur in one direction and could not be reversed. Second law of thermodynamics also introduces us to a new property known as entropy. The second law can be explained by the usage of Brayton cycle. which consists of four processes. The first process is known as the isentropic compression, where the air gets compressed in the compressor under constant entropy. Then, constant pressure heat addition process, where the air gets compressed under constant pressure in the combustion chamber and gets ignited and expands through the turbine and passes through the turbine, causing it to rotate, which is known as isentropic expansion. And last, it is known as the constant pressure heat rejection, where the air will exit from the exhaust nozzle and release heat to the surroundings. Here, the high temperature gas has higher quality of energy, and the energy is being extracted from it to produce work, which then will be transferred by a shaft to the compressor. Usually, jet engines operate on an open cycle, and the air exits from the exhaust nozzle and not recirculated. These four processes occur in one direction and cannot be reversed, which complies with the second law of thermodynamics. That's all from me. Thank you.
Assalamualaikum and good day to Doctor and my fellow friends. My name is Muhammad Akmal Arif bin Muhammad Nasir and my metric number is 207573. As for right now, I'm going to explain for the thermodynamic analysis and also for the conclusion in this video. Okay, let's start with thermodynamic analysis. As for the thermodynamic analysis, we will talk about what kind of the principle that we use in our manufacturing product. As for our report video, we will use a jet engine as our product. Okay, in thermodynamic function for the jet engine, the principle that we use is called Brayton cycle. What kind of Brayton cycle is this? Brayton cycle is a kind of the heat cycle that describe the operation or operative of the heat engine that have air or any other type of gas as their own working fluid. And as for the Brayton cycle, they contain four processes, which are first, isentropic compression, second, constant pressure addition, and third, constant pressure heat rejection, and lastly, for isentropic expansion. Okay, how this kind of Brayton process happen in the jet engine? When this kind of cycle happen, in order for the jet engine to convert the fuel fluid to the gas engine. Okay, let's talk about example problem in this report. Okay, as we all know, when every type of manufacturing product will have their own fixed problem that need to be solved before the final product is happen. As right now, we will take as example for the jet engine problem as a example. Okay, in this report, it is mentioned that we need to find the value of thermal efficiency for the plane jet engine. Note that the value of thermal efficiency is very important in order to know the network of heat output to the heat input of the jet engine, so that we can calculate, and also in order to use what kind of material that's suitable for jet engine. Okay, in this kind of problem, we use thermal efficiency as a thermal efficiency formula. Before we use the thermal efficiency formula, we need to find all kind of component that needed in a thermal efficiency formula. First of all, before we move to the procedure solution, first we know that there are four types of process. So we will divide it into two types, which is process 1 to 2, and then process 3 to 4. And so for process 1 to 2, we need we know that pressure for state 2 and state 1 is equivalent. We need so that we will make a comparison to find the pressure critical at state 2, because in the question they will already be given the value of pressure 2 and 1, and we can find the pressure critical in the table table thermodynamic, which is A17, if I'm mistaken, under the table of gas. After finding the pressure critical the state 2, we will use table thermodynamic to find the temperature and also internal energy for the thermal efficiency. To find the thermal efficiency. Okay, it also happened in the process 04. It is the same kind of solution as we did at the process 1 and 2. After finding all pressure, critical heat, internet energy, and also temperature, we will use a formula which of thermal efficiency, which is N equal to the work net divided by energy inlet. For the work net, the formula is work output minus work input. In the slide show that the formula of the work output and work input. After finding the work on total net, we also need to find the energy inlet, which is shown in this slide, which is H3 minus H2. After finding all energy and work, we will use this in the formula. Okay. In conclusion, we all know that thermodynamic allow the technology to grow and even evolve because there are variety of endless in knowledge that we can apply. And secondly, of the what we get in report is that Breton law can play a very important role in a process of the engine because it involves conversion of energy, which is the basic of thermodynamic law in first and second. Also, the third one is that there are kind of expansion and contraction of type of energy in a process of the cycle in the jet engine. Okay, I think that's all for us in this video. Thank you. Assalamualaikum.